So, hello, Mathis. Hi, Vanessa. I will wait a minute. Perhaps a few more people will join. But I can already start sharing my screen. Okay. I will just start. We're recording the meeting, so yeah, the others can probably just watch that afterwards. So I think the main thing we started last time were starting the data curation with for the publication everybody got assigned. And today we will continue that and finish one of these test studies and see how it goes. Yeah, for me it would be really nice to get feedback also, and if you have issues, just let me know. Yeah, the main tasks so far were that people should create an issue for their respective study. And we see we have yeah, a few people did this already, and one or two also started working on the data curation. So last time I showed the example of the Witte 1984 and started from that. And today we will continue and finish the study. Okay. So just as a quick reminder, the main thing is you have to do is open an issue for your actual study. Then you should assign yourself and give the labels like data and ramipril. And ideal thing is to list the figures, tables, and so on from the publication, which should be curated. Yeah, often it makes sense to yeah, at least here in the issue, to list the things which really should be curated. But in addition, we had screenshots for the figures from the publication, and that it's okay to just put all the figures and tables in the screenshots. Okay. What I'm doing now is just pulling the latest changes, and we see the already a few things happened. There was some work on Schunkert. Give me a second, perhaps I can put this a bit to the side. So there was some work on Schunkert by Victor, and some work on Heman, Hermann, to figure this out, by Ahmed. Okay. I think one important thing in the data curation is always being consistent with the name. So yeah, like here, for instance, I really immediately see there's something wrong with the names, so we have to just check well, what's going on with the names here. Okay. Okay, and normally I just add a comment. Okay, I say this looks pretty good. So we're getting already a list, but this is far from complete. Okay, so let's have a look at the study which we had last time. these studies are all located in the data studies folder, ramipril, and we work with the Witte and mainly worked on the this Excel spreadsheet where we filled in the basically the groups information and the interventions information, and started a bit with this figure 2 with the data digitization. Yeah, like I mentioned last time, the important information about the data curation is available from this curation markdown file here. So there's a lot of information on okay, how to create the studies and how the upload is working. So I will update this right now while I'm trying to demonstrate it. This also makes it's probably a bit clearer what is going on. Okay. So I'm starting PyCharm. I'm just using this also not only for programming, but in this case also for as a markdown editor. Okay, give me a second. Lots of things are opening here. So, and then we have to go to the right project and just file open recent and just open this this XResearch project. Okay. So, and here's also this curation markdown information. Okay. The first thing I will do is I have to fix the links here. So this is all in the here in this development branch of the XResearch. So we definitely have to update here the repository. Fixing the links here. It's working, and yeah, also if you see some links or some stuff which is not working, then just let me know. Okay, here's some preview of the information. So there's basically information on the curation of the pharmacokinetics and pharmacodynamics information, pharmacodynamics studies. And yeah, this document provides resources information how to create pharmacokinetic studies for the PKDB database. Curation tasks are tracked via the issue tracker. And of course, for our project here, we have a okay, this was already updated. This issue tracker and labeled data and the respective substance. And for our case, this is the ramipril. Okay, this is basically what I showed at the beginning. Also, if you have questions and so on, just please ask. I'm trying to make this more like of a live demonstration to show you what kind of steps you have to do and what information you have to read while you work on that. Okay, the people assigned, the people assigned to an issue are responsible for the curation of the respective study, and that's yeah, that's basically it. In addition to this guideline, a very helpful resource is the Curation tab. This is available via the database interface. Our instance runs on XResearch2 pkdb.com, and there we have this Curation tab where all the information is. So in this case, this is basically instead of this server here, we're working with the XResearch XResearch2 server. Yeah. This you don't need. Okay, which provides a searchable overview over available measurement types and substance information. Yeah, as well as for dosing. Okay, here the fields and yeah, available choices can be searched. Yeah, if things are unclear, to incorrect or encounter incorrect or missing information, open issue. Okay, and then we need the issue here in this case. Just open this in our repository so that we can just track this locally. Okay, installation. This should run on. Let's have a quick look. Basically, it shouldn't depend too much on the Python version. You can use 3.8, 3.9, 3.10, 3.11. I probably would recommend using like something 3.10 or 3.9. So so basically Python 3.8, 3.9, 3.10, 11 are supported. Yeah, so you should have an installation of that or Anaconda or something similar. You should have Git or GitHub account. In the meanwhile, you have this. Yeah, you should have a tool for creating this isolated virtual environments. I showed this at the beginning with the virtual env. You should have a lightweight editor with the JSON plugin. Personally, I really recommend to use Atom. This makes a lot of sense if you just use Atom and follow the instructions here. And then you need plot digitizer. This is available here. This is basically for the plot digitization. Okay. Okay, and then the first step, we're basically setting up the virtual environment and installing the package. So in the meanwhile, you should already have like this Git folder and have basically cloned the data in some folder. Yeah, and in our case, this is the XResearch data. And you have a folder with all the information in there. Okay. Okay, so now first step, you should have just a virtual environment. And then you install the PKDB data package. This is basically what I demonstrated last time. Yeah, for oh, here's an example for Linux, and this should work basically on Anaconda works really well also on Linux, but for Windows or Mac OS, this is probably what you want to do. Okay. either make a virtual environment or use Anaconda. And the Anaconda information is available from the Anaconda webpage. And it's yeah, it should work on any system, but in the end, this is basically a downloader, and you install that, and then you will have in your console this conda command, which allows you easily to create a virtual environment, which you can then also use here in PyCharm. Just here, and it's basically I showed how I can set up this virtual environment here, but you could basically add the conda interpreter, and here I use this virtual environment, but you can also use the conda environment, and here you would select just the conda environment you created. So this would basically be this part here. Okay. So and then you can create this environment with conda create. In our environment, yeah, our environments are just called XResearch. So I have to update here the environment names. And in this XResearch environment, you install the PKDB data. So I have here this environment. Basically there are a few things installed. I'm just listing the pip packages, and one of the things which are installed is hopefully the PKDB data here. And so I did basically created this environment, and then I did just this pip install PKDB PKDB data and upgrade to just get the latest version. Up. Okay. Upgrade. And okay, here it basically just it tries to get the latest version 103. So you should have an install of the 103 in this virtual environment. Okay. So at this point, you basically have like an environment with the PKDB data installed. Okay, this is basically this part here. So the first part, set up a virtual environment. And the second thing is that you have to set some environment variables. And this is just that that the upload scripts know which database endpoint you want to use and what your credentials are. And for that, there's basically this .env file in here. And this is basically just saying, okay, what is the database? Okay, you're all uploading as admin because, okay, it doesn't matter. It's just basically a dummy database for our project. And here's a password for that. So it's, yeah, for now, this is all not very secure, but it's like, it's basically a test server. And if something goes wrong, we just set it up new. But these are basically the credentials you have to provide, like to be able to upload to the database. And so the next step is like setting this credentials. It's basically all the stuff you don't have to do because we already have the credentials in here. So I prepared this already. The credentials are provided in the .env XResearch file. And then you have to basically export the variables. Yeah. Credentials provided. Okay, and have to be exported or set on your system. On Linux, this is pretty easy. You would just you would basically just export these variables via this command. So in the console where you want to upload, you would just run this command, and then you have this environment variables, and you can basically just check this via trying to access these variables. This is basically the RP base, user, and password. So you should be able to print that. So you have now variables here, environment variables which contain this information. Same for the password and so on. So this is basically what you have to achieve, that you have environment variables which are accessible via the terminal from which you want to upload. On Windows, there's a nice instruction here, and basically here. I need to check the environmental use and so on. So on Windows, there's a nice instruction how you would do that. And on Mac, there's probably something similar. This is basically how to change environment variables. And then you go to edit system variables, and then you can go to environment variables, and then you can add variables and values. And the variables and values are basically like what is written here in this environment files. This is a variable RP base, the value is XResearch, and so on and so on. So you have to set this 3 environment variables. And for Mac OS, I'm pretty sure this is very similar. If you find a nice short tutorial, just send me the link and then I can add it here. Okay, that's basically it. And if you have done that, now you're able to upload to the database. So the main functionality of this PKDB data package is uploading and managing studies with pharmacokinetic information. And hereby all information of a single study is stored in a, okay, this doesn't make sense. Who wrote that? So all information of a single study is stored in a single folder. We saw this already for the examples. That's basically here. Everything is for a single folder, which can be uploaded via the upload study script. These watch scripts don't exist anymore, so we only have this upload study script. Okay, does that make sense? Genau. The scripts are executed within the created virtual environment. This is our XResearch environment, which we have. As you can see, I'm working on this here right now. I'm in this environment. Yeah. Yeah. Okay. Okay, this way is already documented above. So with the n set. Okay. Now you can run the script, and this is basically the script you would run. It's just upload the study, and then -s and the study directory. Yeah, for example, or to upload the latest study of the ramipril Witte 1984. You would just okay, I just have to see where this is actually located. So it's I would just run the upload study command, upload study -s, and then I go to the directory. In our case, this is the data studies, ramipril, and the Witte. So this is the folder which corresponds to the study. So this one here. and you then just perform this command. And then you the upload script should work. Basically, this is the second step. Your second thing you have to make work is you have to set up this virtual environment, and you have to set the environment variables and try that you can run the upload study script. So basically, are you able to run this command here? You can see I can run that. And then you see the endpoint where it tries to upload. It's XResearch, and it checks if the study can be uploaded. In this case, this works. Yeah, and this will upload this study defined to this API base with a with this credential. Okay. And to upload all studies in some given directory, one can use the upload study. This would, for instance, if we have like more studies and I want to just upload everything which is in the ramipril folder, then I could use this. Okay, but this doesn't make sense for us. Okay, so just I will just remove this, ignore that. Okay, and then this is basically looking like this here. Okay. Let's update the documentation for that. I will just yeah, and if there are questions, please let me know. Or that's for me the main thing is like I will walk through this slowly, because I think this is the main hurdle for most of you to get this working, and then the actual data curation is not too complicated. So let's see, where do I have the where's this screenshot? Pictures probably. Modified. Yeah, this one. So I just want to yeah, I should also copy the command. So this is basically what you should get at output if you run this command. Okay, just saving that. Wait, so that's where the information is here. So this is I just have to look up how this file is called. It's basically the upload study. I have to replace this upload study file. Okay. Perfect. Export. Okay, so we see here now we have the latest screenshot, and this is how should it look. Okay, this is basically everything for setting up the things, and the other is really the curation information. And this section provides the information on how to create a study, so basically how the study folder should look, how the study JSON should look, the groups and individuals, the interventions, and then the outputs and the time courses. Okay, the first thing is really the study folder. We did this already last time, and for the study upload to work, a certain folder structure is expected of this study directory, which will contain files for the PDF of the study, the reference, as well as figures and tables. Okay, the first step is to create a folder for the study with the respective files. We have this for the most of we have this done already, and the PDFs are already in there. So okay, we'll just use the Witte example. That is, I think, much more you recognize again what happened. So the study folders in the studies, ramipril, and Witte 1984. So genau, it contains a study which has to be the yeah, the study PDF, and there's tables and figures and so on. And these are basically the restrictions on the file names. Tables and figures are named according to the naming in the PDF document. The figures should be created as PNG via snapshots from the PNG, and especially the figure quality should be as good as possible. Yeah, information about the study is stored in the study JSON, and then we have this which we create in the following steps. Information about the reference of the study stored in the reference JSON and so on. Okay, and the rest should be I would say pretty self-explanatory. I will just create another screenshot of this folder, and this is basically how this should look in the end. Could I see here the document type? Oh, so strange. I have settings. This all changed with the latest versions. Here probably references, just columns. The type is really good. Okay. So, okay, so we basically want to see the types. So we have the images in here, the spreadsheet, the PDF, and two JSON files. Okay, just creating a quick screenshot for that. And saving this to update this this image here, which is basically this Curation study files. Okay, so I have to save that. Okay, I have to export it. Okay, export as recently used. Oh man, this doesn't make sense. Okay, I have to go to the folder again. XResearch data, and this information is here in this Curation folder, and so these are our study files. And okay, perfect. Replace. Okay, and so in the end, you should have. Oh, what's going on? I just saved it, or didn't I? What did I do? Oh, does it look good? Ah, yeah, it looks already good. I was just confused. Okay, perfect. This looks already good. Perfect. Well, okay, this is our files. Okay, and then we had this study JSON. Yeah. Okay, and there you can basically look at the other information. So I won't go through the rest. The groups and basically what we did last time is yeah, create the study JSON, the basic one, and then added the groups and individuals we didn't do, and the interventions. Okay, I will update the rest of the documents. And basically we went until, okay, we digitized some of the time courses with plot digitizer, went through this here. And we didn't do any tables, but for the tables we would do similar things. So yeah, I highly recommend just follow this document, and if something is unclear here, please let us know, because then we can just write in the document, and that makes it much easier for everyone to work on the studies. Okay, so far so good. We saw that we could upload the Witte thing, and can see that in the database now we have this Witte study. This is basically this one study we have, and there are a few outputs which we created. Basically, we did this a handful of this time courses, and okay. I just have to figure out where I got this from. And otherwise, we have a this one intervention, which was the ramipril intervention. Okay, so let's continue with this study and see what is missing. Yeah, the thing which we could do, we could quickly check if the other studies which already exist are uploading. So if we just have a look at what was done so far, as you can see in Schumkord, we have like already a few items. So here a lot of the this was already created, and this looks pretty good. So I would just download the latest changes and see if this Schumkord is already uploading. I can. This is basically a study about the effect of renal impairment on the ramipril kinetics, and yeah.
Hello, Matthias?
Yeah.
Yeah, I already pushed the changes and pushed it to the database. So the
Yeah.
Schumkord data, it's already in the database.
It was not in the database. You just saw I looked in the, probably you pushed it to the wrong database based on this documentation. No worries about the, I don't know.
Okay.
Like, because
That's the
basically
real,
I only see one stuff. You've just
that's
pushed
the
it.
real site. Yeah,
Okay,
that's it.
perfect. Perfect. Yeah, so that's why I got confused. Okay, that's
Yeah.
already there. It doesn't matter if it's pushed 2 times.
Okay.
Okay, but okay, so I'm confused why the other study was not there. I tried that. Okay, okay, because I just, this is really strange. Okay, do I have to reload that? No way. Yeah, this is, yeah, here you see, there are 2 studies in there. But why is only, yeah, okay, it could be that one is private. Let's see. Okay, so I have to quickly check the Witte document. Okay, ramipril, Witte in the study JSON. The main reason could be that this no, this is X in public. So I'm a bit confused why we don't see this. Something definitely went wrong. Because this should normally be, this should definitely be visible. So I'm really confused right now, because you see also like we see the 2 studies here and also the 2 interventions. But if you go to the actual interventions, we only see 1. So I'm a bit confused why this didn't work. Okay, let's just quickly check. This is also up. This is a show code, and this is uploaded to the Witte. And look, if I click directly on the study, I also can access the data. So something is a bit strange. But the data is definitely in the database. You can see here it was uploaded, and So I can also see the interventions. Ah, yeah, it could be like because it doesn't have any outputs or time courses that it's not appearing in the main view, because we're only showing only as soon as there's data associated with the study, then it's shown in the main view. Okay, that's a bit confusing. That's why the numbers are a bit different. So the data is in, but you can't access it via this direct links. So it's not listed here yet, but you could definitely find it already if I look here. Even if I search for the study, I see that there are 2 studies available. Okay, so everything good. It's just not listed in this main view because there were no outputs yet. Okay, but this looks good. So we already have 2 studies. Very nice. And so other people who worked here, we definitely have something in the Lee and the Heman. So okay, here we don't have the study JSON. So this definitely won't upload yet. But we definitely we have this tabs, which looks also, this looks really good. Capsule solution. Okay, here this is more. We definitely don't need different interventions because this is basically everything is a single dose of ramipril. It's just in different solutions. So we would just use a single intervention for that. Okay, you probably have to. I understand. You have to distinguish it if you map it to the data. Okay, so it makes sense to do that here. But the main thing which definitely won't work is that you give the same IDs here for the intervention. So you probably need I would just give an ID like wheel 5 for the dose, and then you would just probably just call it water, and you would have a wheel 5 for the applesauce, and wheel 5 for the okay, apple juice, and wheel 5 for the okay, that's capsule dissolved and taken. So this is okay. I don't taken. Okay, this is dissolved. So this is a solution. Okay. So we would just call this here just real. This was just taken normally, and these were all dissolved somehow. So this is the real water. Okay. So this is one important thing. The names are basically unique identifiers. And then if you want to use the interventions for the data curation, these have to be unique. So in this case, you definitely need the yeah, you need despite them all being 5 milligrams, you need like different IDs because the data is like split for these different interventions. Okay, also okay, this is not important here, but always try to be really in this just have some rectangular here with the data, and don't put any data anywhere else, because this will be really complicated with the computational processing later on. This probably also won't upload because it's just complaining that it has data somewhere else. Otherwise, this looks, I would say this looks pretty good. Also the groups, yeah, first look is, this looks pretty good. I'm not sure if this is determined as good health, blood pressure. This looks all really nice. But this won't upload yet because it doesn't have a study JSON. You can try this with a Lee. So if you would just do an upload of the Lee folder, yeah, you will get basically the warning study JSON is missing. So this would yeah, often it's like good way. Just try to upload your folder, and you will get like the some warnings and errors, and just try to fix them. And yeah. yeah, sometimes you have to figure out what it means, or you just, if you have no clue, just post the error and ask, okay, what does it mean? What should I do? And if you provide the study name, then it's for me also really easy to do that. So mainly what you would do, like if you have some issues and so on, is basically you save all your things. You commit all your changes. Obviously, I'm working on the documentation. Oh, what did I do with 2M? Basically, you commit all your changes, and then the easiest way is like, okay, if you if it's some small like first try to do it in Slack, just send in Slack the error and say, okay, I pushed my changes, and with the study Lee and so on, I get the following error. And then basically we will answer pretty fast and say, hey, okay, this is a bigger thing, like open an issue for that, or we will give you like directly, okay, do that and that it works. Okay, so here, next step, create the study JSON and yeah, then move on to the actual data. Otherwise, we see there was some changes in Heman. So here I would definitely say, okay, man, if the study is called Heman, then call it Heman. This would be my first thing, and also really follow the yeah, it's often like try to follow the convention as good as possible. So the figure 2, I like that this is like this, but the PNGs should be named lowercase. So okay, and in this case, I would because I know I commented on this issue. This is basically this here. Yeah, here also these tasks are not done. You basically just created the screenshots, but this is not created yet. So I definitely wouldn't check. I would only check that if it's really, if the data is in the database. Before I wouldn't check that. And here I commented on that. So I would. This is our issue number 6. So if you want to reference something in your commit messages, you can easily do this via the hashtag. This is basically fix the PNG names or fix the names or hashtag, and this was the issue 6. And then it's also easy to reference which issue the things are. So mainly, if you know what's going on here, so slow. Okay, and then if I reload that here, then you will see there's basically I referenced that, and you can also see what happened in the commit. So here you basically see that these files are changed, and now the names are correct. So this would be like some typical workflows here. Like, okay, if there are issues, you basically comment and answer. And a good example is, okay, what happened already with Victor here. He basically starts and yeah, if you have issues, it's basically you just comment on your issue, and normally I try to answer pretty fast, or you write in Slack. But this is pretty good. Like if it's related to the study, it's pretty good to just document this directly here. Okay, so far so good. I don't know. With Bea, you mentioned you already started with something, but did you push the data or?
Yes, I will repush the data because I work now on Matcha. Yes.
Yeah, but you didn't push any changes so far, or did you? No. Yeah. You didn't push your files yet, or no?
No.
Okay.
Yes, I pushed it before 1 hour.
Okay. I see it. Perfect. Sorry. I was just okay. Yeah, there we also see a nice example. There we also have the study JSON, but you probably didn't try to upload it yet, or otherwise you would have a reference.
I don't try it.
Okay, perfect. Yeah, your user. Normally you wouldn't. I will add the additional usernames, but for now, you should just add the XResearch username on that, and the reference you updated. Oh, yeah, but okay. Rest looks okay. So here it's this looks also, it looks pretty good. The files are named all correctly. We have the Excel file. Oh, okay, and BI is almost finished probably. With that. Looks pretty good. Here's something missing. Okay, so that will definitely be a bit of issues with the upload, but overall this looks already pretty far. Already a lot of data in here. It's nice. Okay, labels still don't work, but this looks pretty good. And you can see this is also like often how this Excel sheets will look. If they're not finished yet, you just start like with adding columns and so on. And but this definitely won't upload. But we just try to just show some different arrows. Yeah, exactly. Here's basically there are still nuns and so on. Here it just means there are still nuns in one of the table. This is basically in figure 2. So somewhere are still nuns. Okay, this is and you can see here basically the this is one too long this here, and so there are nuns here, and so it won't upload. Nuns means just empty fields. And so you can see now this is basically yeah, it's doing a bit more, and but now it gives you yeah, more errors, and here it's more like certain things are missing or required, and other things yeah, for instance, there's empagliflozin doesn't exist. This is the one case where you probably have to add a new substance. So this would be definitely something for an issue here, where you would open a new issue and say, okay, yeah, new substance required. Okay, yeah. And then you should always reference also the study where this is happening, because for me it's yeah, otherwise I always have to look up your name and on which study you work and so on. And for me it's often easier, like if you just reference the issue. In this case, it's it's either the issue or the name of the study. So in this case, it's the Matcha 2013. Oh man, something's really strange here. This is, I don't want to see that so much. Oh, what happened? Oh, this was Matcha 2013. Okay, and this is definitely, and stuff like that, you just assign to me, and yeah, and we would add a probably a new tag for that. I'm just submitting the issue. So if there are some problems with the database, you would just open also new issues here and assign the where are the labels and assign a special label for that. Database, okay. Okay, so this is definitely a database issue, and I have to add the substance. Okay, so looks okay. Overall, this looks pretty good. Things are getting started. Okay, and of course we have to get we have to stepwise get all this data in, and if everybody's doing 1-2 studies, then we'll have this. Okay, let's continue with the Witte. The main problem were like we had the tabs and the groups, but we didn't have the data from the figures yet. So I last time digitized this data, but it's not uploaded yet. And there are two main things which we have to do. The first thing is definitely to map the data in the study JSON. That means we have to say, okay, we want to upload this table or this figure. And so we have to add this information to the study JSON and basically do a mapping in the here in the outputs and add this table to the outputs. So I will use I think I had an example. Did I have an example somewhere? Examples, Schwarz. So I will just use an existing study JSON and basically reuse that. And that's mainly that you would have like this mapping of the fields in this spreadsheet to the actual database fields. Okay, so let's do this. We're going to Witte. We're adding the outputs, and then we would make sure that we have all the fields in there. Oh, this didn't work. So the first thing we have to say, what is the source of this information? In our case, it's figure 2, and the image is also figure 2. The source is basically the spreadsheet here, the sheet in the spreadsheet. The image is where the data is from, and if you don't, it's not from an image or no, then you basically wouldn't write anything. You would just not put anything here. The output time, we have different outputs. There's either time courses, that's basically all time course data, or there's the type output, which is for single data points, for instance, for pharmacokinetic data. Then we have to map the label. This is crucial for the time courses. We have to add the group. Let's see what else do we have here. The group or the individual, we have to add the measurement type. Measurement type we have. This is the so-called measurement type. We have the substance, the tissue. Then we have the interventions. This is the intervention column. We have the substance. And then what else is missing? The method we have. And then we have the, in this case, our actual mean. And but we also have SD and SE data. Okay. And the unit is also mapped. So this we would read from the SD, and the SE we would read from the SE field. Okay, this looks pretty good. And if we now we have this mapping, and oh, so there's definitely somewhere an error. So what did I do? Somewhere is a syntax error, so it complains about this part here, and it's okay, because I added a comma here too much. Okay, so okay, I will just use a console for upload, then I don't need so much space. I just need to use a new one, then we can look at that. Yeah, this would how you do it in a terminal, even if without PyCharm and so on, you would just activate the virtual environment. You have to set the environment variables. or like if you set it once in Windows or so globally, then you don't have to update that anymore. But I have to export them here, the .env and XResearch, and then upload study, and this is data studies, ramipril and Twitter. Yeah, and now we see we get a lot of additional errors. So there's basically the first error is, okay, label is required on output type time course, and that is important to if you have multiple time courses in one table to distinguish them. A good example is the Schunkert. I think there it happened. There were multiple of this multiple time courses in one of the figures. Okay, not sure what's going on here. Like for instance, here we have the figure 1. Okay. And you can see there are multiple time courses here. Overall, we have 6 time courses, and it's for different groups, and for group 1, 2, 3, and for different substances, for ramipril and ramiprilat. And then you should give different labels for the upload. And here the label basically has to be unique for the time course. So here with the label, you say basically all these rows belong together to a single time course. And that's why you need for a time course, which consists always of multiple rows, you need this label column to basically say this belong together. This is what you use the labels for. And later on, if we work programmatically, we access, of course, the whole time course also again via these labels. Okay. So this is what the labels are for. And so we need, in our case, this is simpler because we basically have a single time course in here. So we need just one label for the, what's going on with my mouse? We need just one label for the complete time course. So in this case, I would just call this ramiprilat, because we don't have any other time courses. So, okay, and I have to, of course, put it in the label column here. And then this error should already be solved. So I will just retry the upload. And this is normally how you would work. You just set up somewhere this upload for the database, and then you create the study, and then you try to upload it from time to time. And now you can see, okay, this already worked. And also by clicking here, you can open directly the data set. And now you see, now we have the 2 studies in, and basically the, I just filter here via the Witte. You can see that we now have like also time courses in the database. So via this mapping, we achieved that this additional time course is uploading, and this looks pretty good. Like it looks like the data which we curated. So this is basically this information which we uploaded now. Okay, perfect. So this part worked. So we have to check what else has to be done for this study. As far as I remember, there were also like was a table with there was a table with a what is going on here? Okay, just go away. There was a table with pharmacokinetic parameters. So there's much more to do. So basically what we did is figure 2. I can give this here a check mark, but there's a lot more figures and also a table. Okay. So let's have a look at the table. And the table, as far as I remember, yeah, these are pharmacokinetic parameters. So I will just start now to create this data. And for that, we add a new spreadsheet. So this is basically our table 2, which we want to do now, and this is after the current sheet. Okay, this looks pretty good. We put in our table, our figure for the equation, so that we know what we have to do. And in this case, I also would just copy my headers that have a nice template for what I have to do. Yeah, things is also yeah, many things are similar. Like for instance, we know the pharmacokinetic parameter was calculated on the same group. So the group information is already correct. The intervention is also correct because the only intervention here was ramipril of 10 also. And now it's the big question is what was measured. So this is not concentration now anymore, but these are different pharmacokinetic parameters. They were definitely measured for ramiprilat. And they were measured in the serum. This I don't directly know from here, but I know this was measured in the serum. And the parameters were calculated on this time course, so I'm pretty sure this are also serum parameters. The method is the same because these are just calculated from the other one. Labels I don't need because these are outputs now. Times I will probably need for certain things, and then I need, of course, values and so on, and the right units, depending on the parameter which are here in the table. Okay, so I will go to the study JSON and say, okay, now I want to upload also something else, and what I want to upload is the table 2. This is now not time course, but these are simple outputs. So if something doesn't consist of multiple time points, it's just an output. The label we need basically for the time courses, and everything else, the mappings are the same. Okay, and then we can check again if this is uploading. Probably not, because some information is missing. But it would now try to basically upload these two tables, and we see here, okay. So image is an incorrect type. Expected received string. Okay, something is strange here. Image tab 2 should be basically correct. Yeah, so there could be some other problems, but the output is basically this measurement type. It can't be empty. It means like this is not uploading because this is empty. I quickly have to check that really my table is called like that. I could, yeah, basically it's table 1 I want to upload. So of course, it's complaining that it can't find an image for table 1. So we, yeah, basically here it's table 1, not table 2. But these are typical errors which are happening. So this has to be table 1. Okay, should have solved the first issue, and the second one is here now. Now we have to somehow get all these values in here. Okay, so what do we have? We have 1, 2, 3, 4, 5, 6 values. Okay, so let's just create 2, 3, 4, 5, 6 rows. Here we need also the min and the max. So probably I should put this in the templates also. So we have to somehow encode the range. But otherwise, this is basically mean, SD, and range. And then you always have to look at the special things. So certain things are median here. So we will probably need the median. And then be careful that we put the right values in the right areas. So I will first type in the values, and then and then also make the comments. Okay, so let's start with the values. Okay, we have the mean is okay, we have basically 24, and the SD here is 16, and this ranges from 5.3 to 49.5. And these are also the large variabilities in the pharmacokinetics I mentioned. This is really like big differences between the different subjects. Okay, next values which we have in here is the 62 with an SD of 41. In this case, often I rearrange the columns just that it's matching what I have in the tables. That makes it much easier to just type in the values. And then you have a 14 and a 27. 27. Then we have a 3. This is now a median. We have to put it in the right column. And we have the 1.5 no SD to 3.0. And then we have here again the mean values 414, an SD of 124, min 231, and 577. And okay, have to be careful about the 113, and the 85 and 190. Here you would also write the comment here. Basically, here we have one outlying value of 245 hour. So this is something we just write down here in case this value seems to be really strange, that we can perhaps have a clue what's going on. And then the last row, SD 629 and 580 and 2205. Okay, good. And then basically we have all the values. We still need the units, and we have to say the database what is this actually, what the values are for. So here we know this is nanograms per milliliter. This is nanomole per liter. Then we have hour, nanograms times hour per milliliter. Half-life is an hour, and then we have microgram. Okay, so what are other things? The first thing is observed peak concentration and peak concentration. And then we have basically two times these things, one in different units, and this is just converted via the molecular mass or molar mass. Or, yeah, so this two data is basically the same. So we would just exclude one of these so that we don't have duplicate data in the database. To exclude rows from upload, you would just prefix it with the hashtag, the first row. So this row is basically not uploading, and I would just to make a quick comment, duplicate of first row, so we don't care too much about that. We have to. The main thing we still have to figure out. Okay, what are the measurement types? And that's again like going back to the database and looking in the Curation tabs. And we are maximal, with something with a maximum concentration. This looks already pretty good. Maximum concentration for given substance, Cmax, and so on. This looks pretty good. So we would use here the this field and put it into the database. So yeah, this makes observed peak concentration. Yeah, this looks pretty much like a Cmax. Cmax. Okay. Then we have a time to peak. This is Tmax. Or should be Tmax. Yeah, here. This is time to maximum, Tmax. So you should also find this. Then we have a AOC, and here is given a end time. And this is important because there's AOC inf and AOC, the normal AOC. So the AOC, and then we have to provide the time. This is basically the AOC until 336 hours. Then we have a half-life. So this is Tmax and Cmax. Half-life, especially here, it's a T half. We can put in the half-life, T half. And in the end, we have like something which is urinary recovery. Okay, we'll just also quickly look if this is in the database. So there's something which is called recovery. Fraction recovered of given substance, and we should use it with a tissue where the substance is recovered. For instance, we should use it with the urine if you want to do urinary recovery. Okay, that means, okay, this makes also somehow sense because the amount recovered in the urine was definitely not measured in the serum, but this was measured in the urine. And this is the recovery of the substance in the urine. Okay. So this is basically it. That's now we have all the information. We know, okay, there was given ramipril 10, I think 10 milligrams, and we measured the maximal concentration in the serum of ramiprilat with a HPLC, and the values are basically that, and similar with the other things. So this is all well specified now, and we can check if this is uploading. Exactly here. AUC does not exist. This was normally if the measurement type doesn't exist, you should just check if you have a typo in there, or if you use something wrong. For instance, we see we have a lot of AUC, but here this is basically the AUC end. This is area under the curve until last time point. So this is what we have here. It's like the AUC which was calculated until 36 hours. If it was would have been interpolated until infinity, you would just use the AUC inf. So here we have just the wrong name. This is an AUC end. And then we can check if we fixed it. Okay, here, unit. For measurement type recovery, the unit microgram with the dimension mass is not allowed. Only units with the following dimensions are allowed. Dimensionless units, exactly. And that's okay, that's not a problem, but this is just a basically an issue with being precise. So like we probably didn't read what recovery is really. Because recovery is basically meaning fraction recovered of given substance. That's okay, and that's not what we have. We have basically a total amount of substance. So recovery would be, for instance, 57% or 57% of the dose were recovered. So, and this is of course dimensionless because it gives you just a percentage of what you have given is recovered against in the urine. But what we want is here basically to store the amount which was excreted, use cumulative amount. So okay, yeah. So the right thing to do is here cumulative amount, and this also has the right units because we can provide it in grams or in moles. So it's basically again like the wrong measurement type. It's basically like something the units are not mapping to what we say the measurement type should be. Okay, and then let's try it again. And this is typically the workflow, like here. And here for the measurement type cumulative amount, the key time is required. And this makes also sense. Like if we are interested in when it was recovered, like it makes a big difference if we measure after 10 hours or after 100 hours and so on. And to figure out when it was measured, we basically have to figure out, okay, when was the last urinary sample taken? So it's more like if we don't know anything, okay, I open that again. The first guess would, okay, this was probably also after 336 hours. Yeah, but but we're not sure. So in cases like that, it often makes sense to just go back to the actual publication. So let's figure out what was done. And so it should be most likely in the method section here. Okay, we see. And here we see urine. Okay, urine was collected before and 90, 69 to 120 hours after dosing. So they definitely didn't measure at 336 hours, but the cumulative amount which was recovered is until 120 hours. Okay, because this was the last time point they measured the urine. It's a bit of shame that they didn't provide the urinary data. But they have at least the total cumulative amount which came out. Okay, so that's basically what is missing. We know it's a cumulative amount and it was measured after 120 hours. Okay, let's go back. Okay, that looks good. It has uploaded, and now we have also data for the additional table in here. Yeah, this is more difficult to see, but it's more like if you go to the outputs, yeah, we see that we have like information about of the time of maximum, area under the curve, cumulative amount. This is not rendered very nicely, but we have all the information in here. So we have lots of concentrations from the time courses, but we also have things like maximum concentrations, and so all this data is now in there and can be used for modeling. Yeah. Okay, always with stuff, if it's working, we just commit it. Okay. And often it makes I just saving all my files here and closing everything what I opened. Here's basically the first upload of Matcha 2013 and tab 1 of it 1984 created, and then we can push these changes again. So someone else did something in the meanwhile, so I can just do a git pull. So yeah, probably yeah, we have to be careful that we don't break the Excel files. Normally only one person is working on the Excel files, so I have to solve this merge conflict. I hope Bea didn't Bea probably continued working on that. Okay, I have to have a look at the matcha. Basically, I will remove that, change that, and so yeah, Bea has to make just make sure that you push your changes. I didn't do much at the file. I just removed this one field you saw in the first table. Git add later. Oh, good. Not all conflicts. Commits each. I have to figure out what something I broke with the files. It's each. Use git commit to con. Merge conflicts. Okay, and then I could push my changes. Perfect. Here's data. I think this is this filter, which is not strange data. Yeah, but now we see we have the two studies in here. Okay, looks pretty good. And we can see we get more and more basically time courses, and this will be the data which we use. And we see like by Victor's study, they didn't have error bars, but here we have like one example with error bars from the Witte. Okay, so far so good. So I would say the main thing you have to do now is really curate your data. That is the thing. Like, or if you like, basically, if you're really fast and if it's really simple for you to do the things, then you could also create a second study. The main point is like what we need for the project is you basically need this basically this data like we need in here, and you can see like probably everybody has to do around two studies, but it depends on how much the people are working. I expect that a few people will just they will just jump boat. But we clearly see the main thing is like we clearly see who contributes, so that's for me also the main thing that we why we track that, because then it's pretty clear who is doing what and what where something is already happening, and then at some like basically at some point if we have the first round of studies, then the people who didn't do anything, they just have to I don't know, they won't be on the publication or something like that. It doesn't make sense. It's okay if you just listen to the lecture, but you have to contribute actively to the project somehow. And the contribution is definitely okay. Doing doing one or two studies and also doing the simulations for that. And this is, I would say, overall, it's not too much work, but of course, it's important for the overall projects, because if you only have 3 or 4 studies, then it's getting basically impossible to build a good model with that. But if everybody's contributing a bit, then it's easy to build something very nice. And it's of course like also the so yeah, it would be great if you can start this week the missing studies, and next week we basically would do the whole body model for the ramipril and create a first simulation where we say, okay, we have a first dummy model, this can create simulations, and we compare it against our first data sets. Now our first data sets would basically be this with the Schunkort looks also pretty good. I like that. Yeah, a bit of problem is it's like renal impairment, but for a first test simulation, this is sufficient, because here we basically have to say we need a model and then we have to simulate the renal impairment. So we need first a healthy model. And that's not data to fit a healthy model. But otherwise, the data of matcha could also be a first test case, because this looks really okay. This is mPlug. Yeah, here, because we see we have really nice ramipril and ramiprilat concentrations. Okay, so far so good. Are there any questions? Or
Yeah, I have a question about the intervention. So there's like a shortcut for encoding multiple doses, which is in the curation document. I tried using it, but I don't think it rendered properly on the database.
can be. This is mainly for the okay, let's see. Yeah, I want first to see if you really need that. So okay, so it's basically for the okay. Just tell me for which figure.
Actually, so the intervention, like the treatment, it was a daily dose for like 2 weeks. So I had to find a way to encode like the daily, like the once every 24 hours for 14 days. So in the intervention tab, the intervention, yeah. Can you go to the, yeah, exactly, the time, like that shorthand for
This is correct. Yeah, it's unclear. You definitely need don't need a time end. This is for the infusion.
Okay.
It's more like, okay, here it's more the yeah, it's basically but this makes a lot of sense. This looks good. Let's see what we but I must like I have also no clue. I basically have to read this document here. So sorry for that, but it's seriously it's the same for me. Like there's this document is really here. It's like here exactly. If you have multiple dosing, that's a good point. Like if you not have a single dose, you should basically use that. So yeah, the start point looks good. Okay, it doesn't look. Let's see. We have to look with the figure if this looks good. But the T means basically the time for everything, and R the number of repeats. Okay, so that's basically you have a dosing. This looks overall. This looks good. You just have to check if this fits to your to your data. You know, because here you basically say, okay, you start at time 0, and then you give 14 repeats. And then you were somewhere at time 312 and so on. And then you use this probably for this data.
Yeah, that was the only.
But exactly, but your data is basically starting at 0. You know, so basically what you want to say is let's say the big question. Okay, in your case it makes sense because it's basically they give every day a dose. And then it goes until 312. We just have to like often it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So yeah, here you the big question if they said for 14 days, it's probably 13 doses, you know, like because I don't think they gave another dose here on the last day, but it could be that they gave 1 dose before the first time point. That's the point. You have to figure out what they did exactly. So I assume they really started the dosing here. Basically, they take a measurement and then they start the dosing, and then they do every day the same. That people come in the clinics, they measure this concentration, and then they take the tablet. And so overall, I think they probably took 13 repeats. That would be my first guess, but please check that. And otherwise, this looks pretty good and fits to this. Fits to the simulations. This is probably your data which you had in the. I don't know what this is here.
Yeah, so those were the like the x-axis actual values. I just put them there because like I used the ones on the graph, but I just put the raw.
Makes sense. For stuff like that, don't put it in the comments because the comments are uploaded to a field. You can really, if you want, add like new dummy variables. These are just not uploaded to the database, but you can create here just, I don't know, just call it X values or whatever. And then you, this is nicely stored, but use the comments only for things which are related to the, I would say, data quality or something which is wrong. Okay. Otherwise, yeah, and here the big question is, okay, yeah, here you have to be, for this you have to be careful because this is basically, this is under steady state condition. So this is day 12. So you have to be careful. This is probably also the last time point. So this is probably okay. You always have to check if, for instance, if this would be like, okay, measured on the first day. Sometimes they do that, like to compare the first day after 14 days of dosing. Then you would, of course, need a second intervention. You would one intervention where you say, okay, I gave it for 13 days, and need one intervention where I gave it for 1 day. So this is the only thing that you always have to be careful that your interventions are fitting to the actual curves and have the right offset for the simulations. Like, yeah. For instance, if you would have like, okay, I gave 14 days before I measured the dose and I've started measuring at 0, then you would of course start in the intervention with an offset. You would here write just minus 312 and say T24 and then repeat 13 to just say, okay, we did this like the 312 hours before we started measuring and then we measured at time 0. But in your case, it's both starting at time 0, so it's okay. Okay, perfect. Thanks a lot. I will just save that. Okay, and any more questions? Or otherwise, I personally can say just start creating, start working on the files, and then questions will come up, and then just ask the questions in the chat. So this is or in via GitHub issues. That's yeah. Okay. Otherwise, I will make the video fast available this time. And yeah, so if you have questions, just let me know. And otherwise, yeah, have a nice week.
Thank you. Bye.
Bye.
Thank you.
Bye.